Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, depreciation, and in continuation with the finding derivative of some basic functions. Today, in this very lesson, I'll take you through finding derivative of logarithmic function. So let's begin. After completing the very lesson today, my dear student, you'll be able to find the derivative of logarithmic function. This is what I hope you'll be able to do after completing the very lesson today. So as usual in your favorite segment of the lesson, Mars is fun. Today I will introduce you to another special, the number 7. This number 7 is so special, so interesting. I'll explain what is interesting about this very number today after completing my lesson, so don't go away. To begin the lesson, let us first learn the rule that will guide us to find the derivative of logarithmic function. So the rule says if you have the function y equals to ln fx, the ln here indicates that it is a logarithmic function. So derivative of this ln fx is nothing but d by dx of fx divided by fx. So just to find the derivative of the function x itself, then divided by the function fx. We're going to take examples how we can make use of this rule and find the derivative of some logarithmic function. So let's just move and take examples. Example number 1, it says find the derivative of y with respect to x if you have y equals to ln x raised to the power of 5. Solution to this very problem. So what do we now do? We now write the rule. The rule, remember, says d by dx of ln fx. This is nothing but d by dx of fx divided by fx. So in this case, you can take x raised to the power of 5 as your fx. X raised to the power of 5 is now your fx. Then what will now be its derivative? Let's just move ahead and do it. So this will now be equals to dy by dx of this very function y. That is the question asked, the derivative of y with respect to x. This will be nothing but d by dx of this ln x raised to the power of 5. So if I continue, this means d by dx of x raised to the power of 5 over x raised to the power of 5. Derivative of x raised to the power of 5 is nothing but 5x raised to the power of 4. We learned that in our previous lesson. That the power of 5 will reduce by 1. And it will now multiply whatever number here. In this case, it is 1. So 5 times 1 gives you 5 over x raised to the power of 5, which is your fx. So this is the derivative of this very function. So let us move and take another example. Example number 2, it says find y prime if you have the function y equals to ln x. Solution to this very problem. Y prime simply refers to derivative of y with respect to x, that is dy by dx. This is another meaning, another notation of derivative is y prime. So let me just write the rule. The rule, remember, says derivative of logarithmic function. The ln here indicates this function is a logarithmic function. So d by dx of logarithmic function fx equals to d by dx of fx over fx. So in that case, I now have d by dy, that dy by dx of this very function, that is the y prime, would now be equals to d by dx of ln x, that is my function y ln x. And there I continue. I now apply the rule. The rule says d by dx of ln x is nothing but d by dx of fx divided by fx. In this case, my fx is just x. So I now substitute there. I now have d by dx of x over x. The x, like I've said, is your fx. So derivative of this x has power 1. That 1 will now multiply the coefficient here, which is also 1. So 1 times 1 will be 1, and that power 1 will reduce by 1. So it becomes 0. So I'm going to have 1 over x. 1 is the derivative of this. I repeat, that power 1 will reduce by 1, so it becomes 0. So I'm going to have whatever raised to the power of 0 is nothing but 1. And I have 1 here, so this is 1 over x. This is the derivative of this very function. So with this, I have come to the end of this very lesson, my dear students. I hope you enjoy it and you also be able to find the derivative of logarithmic function. Thank you for your attention, and let me just move to the last segment, MathsClass. So what is interesting about this very number 7? Dividing 1 by 7. If you have to perform this very division with your calculator, this is what you're going to have as your result. 0.142857142 like that. Also, if we are to divide 2 by 7, if you did correctly, this is what you're going to have, 0.285714285714. Let's attempt to divide also 3 by 7. This will now be the result, 0.42857142857, and so on. Let's just do one more division by 7. I now divide 4 by 7. This will now be the result if you did correctly, 0.571428571428. So looking at this result critically, that is a result of dividing 1, 2, 3, and 4 by 7 each. These are the result. If you look at this result critically, you discover there is a pattern. A pattern of this 142,857 appearing in each and every result. Let me just underline the patterns. Look at the patterns of numbers. In this result, you can see this pattern appear even twice. It has repeated. In this result, division 2 by 7, you can see it started with 2857, then 142,857, and it continues. If we are to continue this division, this will also repeat. And even this first few digits is just a part of this 142,857. Similarly, division of 3 by 7 also contains this pattern of 142,857. And where it started, you can see 42857, and if you to continue, it will repeat. Similarly, division of 4 by 7 also contains this numbers 142,857, and it keeps repeating. This is interesting. Division by 7 of these numbers from 1 to 9 contains this repeated digits 142,857. We see more of this and other things in mathematics in our next lesson. Thank you for your attention.